Alright, greetings to you. Welcome back. Today we are going to look at integration by parts. Integration by parts. Alright, so when we say about integration, or when we say integration by parts, what do we mean? Now, you can recall from your calculus 1 that we do a case where two functions are being multiplied. Let's say that f of s and g of s. When these two functions are being multiplied, then we say that let's apply what? Product rule. So, in the same way, now that we are in calculus 2, when two functions are also being multiplied, can we take the integral of it? And the question is, the answer is yes. We can do that. In what way? Let's look at it and you will have it. So, we are going to prove it from what? A product rule. So, from product rule, we know that if you have the derivative of f of s and g of s, we treat this as what? A product rule. So, you leave this, then you differentiate this. I hope you can see that. Alright. Plus, now differentiate this and leave this. Very good. And that is the derivative what? Function. That is the derivative function. In the same way, in integration, if you want to integrate, we know that integration is a reverse process of what? Differentiation. And for that matter, to integrate two functions where they are being what? Multiplied, we can integrate both sides here as respect to s and integrate this side as respect to what? X. Very good. So here we know that anytime you have a derivative function and you integrate it, you get a function back. So when you integrate this, it will do the derivative, so you get f of s times g of s to be equal to. Very good. Then, with this side, we repeat f of s g prime of s. Don't forget that here you can integrate it term by term. So ds plus the integral of f prime of s g of s ds. Very good. Now, here what we are going to do is that let's maintain this on one side. Okay, let's maintain this on one side. So when we maintain this on one side, that means that we have to move this to what? To the other side. So we maintain f of s and the g of s here. Then we subtract this from it because it's crossing the equal sign. So integral of f prime of s g of s ds equal to the integral of f of s g prime of s ds. Very good. Now having this, then as we do in product rule, when two functions are being multiplied, you set one to be equal to u, the other to be equal to what? V. In the same way, we are going to let u to be equal to f of s and v to be equal to g of s. The reason why we are doing all this is to get rid of all the f and the what? The g. So we are going to do substitution to get rid of all the f and the g. So here, when you differentiate this, you get du is equal to f of s ds. And when you integrate this, you get dv is equal to, f prime d prime of s ds. Very good. I hope it's now clear to you. Now we are going to do substitution. Wherever we see u, wherever we see f of s here, we put u there. And wherever we see g of s, we put v there. And wherever we see this form, we put v there. Wherever we see this, we put u there. So here we get u times v minus integral of f prime of s. We know that f prime of s ds is f prime of s ds is du. And we also know that g of s is v. So here is v du, which is equal to, then we come to this side, the integral of f of s is u, then we have g prime of s ds to be dv. So finally we get the integral of u dv to be equal to u times v minus integral of v du. Very good. So this establishes our idea in how we integrate functions, two functions being what? Multiply. And that is the idea of integration by parts. Alright, I hope it's clear. Now, let's move on. Let's move on to take note of some things. Make sure you write it. Good. So notes. Notes. Now, the question is, when you have a function f of s and g of s ds to integrate, the one to pick as your u and the other one to pick as your dv is the most important thing. Alright, well, let me go straight to the point. The one to pick as your u is what we are going to emphasize on here. So let's look at this. Note, choose u so that the integral of v is possible, and so that the derivative of the u is better. So what are these means? What we are going to look at it right now is what I call the critical stage in integration by parts. Alright, so choose u so that the integral of v is possible, and so that the derivative of the u is better. For instance, I will solve solve this, I just want to introduce you before we solve questions. What I mean by this saying, if you have S mean S, ds to integrate, and you mistakenly pick your u to be S, and your integral, you mistakenly pick your u to be S, then how are you going to integrate with S? I know that when you differentiate ln S, when you differentiate ln S, you get 1 over S. But have you been taught how to integrate ln S? Do you know what you get when you integrate ln S? So this one, even though when you integrate ln S, it will work. We have integral of ln S. But you will see that that will not be possible for you for now. That will not be what? Possible. And also, the derivative of the u will also not be what? Better. Alright? So, like right now, what is integral of ln S? Don't know. Very good. So, choosing of the u is the most important thing. Alright, so let's try on the first question. Now, let me give you the general way, but I'll give it to you later. 1. Integrate S equals S ds. When you are given this question to integrate, the first thing to do is to pick your u. Alright? So, here we let u to be x. Then, how are we going to pick our v? Watch. If u is equal to x, then v will be equal to, if you pick s out, watch. What is left in the integral function? E raised to the power s ds. In short, your v is going to be everything left. Everything left is going to be your what? Your v. I hope you get it. So v will be integral of e raised to the power s ds. Now let's see if integration is going to be possible and differentiation is going to be better. Very good. So when you differentiate du, you get 1 ds. Very good. And when you integrate this, but when you are about to integrate, this becomes dv. So when you integrate this, you get e raised to the power s. Yes, after integration we add plus c, but here don't add any plus c. Alright, so that is that for that. Now, let's go and do substitution. You know from the formula we derived that the integral of u dv is equal to u times v minus the integral of v du. Know this off here, alright? So now, the integral of u is what? S. And dv is what? dv is e raised to the power, so let me bring the s here. E raised to the power x ds. So we are doing substitution. U is what? X. V is the integral of V is the integral of e raised to the power s, and that is what? E raised to the power s. How we can see that? Alright, that is the V. Minus the integral of V is e raised to the power s. E raised to the power s. Then our du is going to be 1 ds, which is the same as ds. So we now integrate this. So when you integrate s e raised to the power s minus, integrate this, you get e raised to the power s plus c. So here is when we add the plus c. That is all for that. So we get the integral of this to be this. Now, you can choose to apply your algebra. We can factor e raised to the power s, then we get s minus 1 plus c, and that is all. I hope it's clear. Let's look at our second example, and I will generalize something for you later on. Let's look at this question. I hope it's not difficult. Here you let u to be equal to s. V is everything inside. Sorry, everything left. So V is integral of e raised to the power s ds. Very good. Then you differentiate this. U is equal to this. Integrate this. When you integrate this, you are going to get what? E raised to the power x. You don't let me bring the v. So when you integrate this, you get e raised to the power s. And there is no, you don't bring these things, alright? If not, you will be confused. V is equal to this. So when you integrate this, you get e raised to the power x. Don't add any plus c. Alright. So now, by the formula, we know u is s. You know the v. And the v is going to be what? You know that the v is just going to be e raised to the power s what? ds. You should be able to what? Know that. Or in another term, you write integral of this, bring the whole question back. Bring the whole question back. Is equal to u is what? S. V is what? That. Okay? And when you integrate that, you get this. So this is v minus integral of v. V is e raised to the power s. And we are integrating this as respect to what? X. And that is that. Question 2. In the same way, u is equal to s to the power 3. And as I said, I will generalize something to you. And if u is this, the rest is what? V. Hope you can see that. So, the u is going to be equal to 3s squared. And V will be equal to e raised to the power x. Don't add plus. Therefore, the integral is equal to, and what is the integral? The integral is the integral of s to the power 3 e raised to the power s ds is going to be equal to uv. So, which is u? U is here, s to the power 3 times v, which is e raised to the power s, minus the integral of v, and the v is e raised to the power s ds. I hope you can see that. Oh, sorry, du. And what is du? The du here is representing what is here. du is 3s squared, and we know that here is du over what? ds. So we can write it as du is equal to 3s squared ds. So we bring ds because we know that the du here is representing everything what? Here. In the same way, that is what we did to this side. The du is 1 ds, and we know that this is the same 1 ds, and we brought that. And even if you don't know, after writing, even if you forgot to bring the ds and write du is equal to 3s squared, know that we are integrating as respect to x, so we bring the ds. This resolve to. Alright. Now from what we have here, we can bring the constant 3 out. Then integral of e raised to the power s. Hope you can see that. Then s squared ds. Now you can see that we have gotten another product again. There is a repetition of another what? Product rule. So we go for that. There is a repetition of another integration by parts. So we go for that again. So we are going to don't forget that here is I is equal to this. Let's represent this by I is equal to this. That is the first. The I represent this. So we are going to let I2 be equal to e raised to power s times s squared ds. So you go and integrate this again. So I2 is going to be equal to u times v minus the integral of v du. So u will be s squared. Then your v is going to be equal to the integral of e raised to power s ds. So you get du is equal to 2s ds. Then the v is equal to e raised to power s. So by substitution, I2 is going to be equal to u is what? S squared times v e raised to power s minus the integral of v, and v is what? V is e raised to power s. Then du, and du is the whole of this 2s ds. I hope you can see that. Wow! There's a repetition again. You see there's a repetition again? Alright, so let's move on again. So and when you are doing that, don't forget your back. That here, what we have here is I is equal to s to the power 3 e raised to power s minus 3. And this represents what? I2. How you can see that? Very good. That represents I2. So now, here too, what we have here, we are going to let I3 represent the whole of this. So this we get integral of e raised to power s 2s ds. Therefore, I2 is equal to s squared e raised to power s minus the whole of this, and that is I3. I hope you are following. Keep following. Now, we can let u to be equal to 2s, v to be equal to e raised to the integral of e raised to power s dx. This is I3, that's what we are doing. So du is 2 ds, v is e raised to power s. So I3 is now going to be equal to, hope you are following, uv minus v du. Know the formula of head. So here u is what? 2s times v e raised to power x minus the integral of v is what? E raised to power x du, and du is 2 ds. 2 ds. Very good. Now you can see that we can integrate this straightforward because what we have here is a constant. It is not a function but another function. Even though constant is a function, but we know that we can integrate functions straightforward. But we know that having an integral function embedded with what? A constant, we can plot out the what? The constant. So here we can get 2s e raised to power s minus 2 integral of e raised to power s ds. I hope you can see that. So here we get 2s e raised to power s minus 2. And when you integrate this, you get e raised to power s. Very good. So the last time you add plus what? C. But I won't like you to add plus C for now, but you can still add though. I want us to do something, but don't forget that I3 is equal to this. Wow! Remember that that is not our final answer. Because we know that we are looking for I, not I1, not I2, and not I3. I said here is what? Okay. I2, I3. Oh, we should have rather make it I1, but don't worry. Let's make here I1. I1. You don't worry. Let's maintain it. So this will be like I1. Okay, this will be like I1. Let's maintain it. Alright, so in the first place, what we did is that we set our u to be equal to this, our v to be equal to whatever is left. Our v to be equal to whatever is left. Alright? Then you differentiate this, you get this, differentiate this, you get this. Now, when you put down the formula and you do the substitution, you are going to get this. But here, we realize that this one repeated here is another integration by parts that we can apply to solve it because it's two functions being what? Multiplying. And for that matter, we said that then let's represent here by what? I2. So we let this to be equal to I2. That means that I1 is just going to be equal to this, or the integral, the original question, is just going to be multiplied by what? The I2. And we integrate the I2 by integration by parts. We go through the procedure and we have I2 to be this. Now, what we are having here is also should be done by integration by what? Part. Because it's just two functions being what? Multiplied. Then we say that then let's go back again and set our I3 to be equal to that. And when you integrate it, so the I2, the whole of the I2 is going to be this minus the I3. And when you come back and integrate I3, let me write that here. I3 is integral of e raised to power s to s dx. Okay, so when you do that, that is what you're also going to get for that, and that becomes what? I3. Very good. Very good. So that is I3. So we now come back and do the substitution back because we are not looking for I2 and we are not looking for I3, but we are rather looking for what? I1. I1. That is the original integration. Alright, so here, let's move on. So I1 is equal to, now watch what? S to the power 3 e raised to the power s minus 3 multiplying what? I2. So you come back and look for I2, and this is I2. I hope you can see that. So I2 s to the power 2 e raised to the power s minus I3. Alright? Then you come back. Then where is this I3? And this is that I3. Then you come back again. Therefore, I1 is equal to s to the power 3 e raised to the power s minus 3 s to the power 2 e raised to the power s minus I3. So where is this I3? This is that I3. Alright? Okay, so this is that I3. Don't forget that we did not factor these two out. Okay? If you factor these two out, then the u there will be x. And for that matter, you are not going to affect the I3 by what? 2. But when you factor the I2, sorry, when you factor 2 out, the 2 multiply the whole of the I3. So don't forget that. Alright. So with this, we maintain u to be equal to 2x there. So, alright, so that's what we are going to get for I1. And here, we know that the I1 is the whole of this original question that we are solving. So, the integral of s to the power 3 e raised to the power s ds is going to be equal to s to the power 3 e raised to the power s minus 3. Then the 3 is affecting the whole of the inside. So the 3 will multiply s squared e raised to the power s minus. Don't forget that this negative 2 affects this. So here will be positive. So 2, 3, 6. So 6s e raised to the power s alright, so 6s, because 3 multiplied this, you get 2, so 6x e raised to the power s. Then negative will affect this one. So we also get plus, follow. You will also getting plus 6, another 6 e raised to the power s. Then the last one is plus what? C. Alright? You can choose not to even bring this plus C, but after everything, then you add the plus what? C. So this is what we get for integral of this. But we can still factor something out here. We can factorize e raised to the power x, then we get x to the power 3 minus 3s squared plus 6x plus 6 plus 1. Sorry, plus c. So that is the final answer for solving such what? Question. Very good. Thank you. Let's see for our third example, and you will love it. So in our third example, so now I hope you have realized something, that anytime a polynomial, if we are saying integration by part is when two functions being what? Multiplied. So we have realized that anytime a polynomial, and that polynomial, let's say s raised to the power n, we don't care about the constant, and we don't care about the power here, alright? When it meets with a natural logarithm, like e raised to the power x dx, when it meets with a natural logarithm e, then we always do that. We set our u to be equal to this. Then our v will be the integral of e raised to the power x dx. Please take note of this generalization for me. Anytime a polynomial meets with a natural log, which is also a function, u is this, then the v is everything else. Don't forget that concept. Alright. Good. Sorry, I said natural log. Exponential function. When a polynomial meets exponential function. Let's see question 3. When a polynomial meets with a natural log, let's say e ln x dx. Very good. Having this question, how are we going to do it? We have first talked about it. Now let's see how we can solve it. Here you can see that you don't know the integral of ln s. So if we set our u to be s and the rest become v, we will suffer here, alright? Because we don't know that. And even if we know, let's assume we don't know, because the integration and the derivative is not going to be better. Even though it is good that you can differentiate x, but it will not be better for you, alright? So here you set your u to be equal to ln x, then the rest become v, which is s ds. So when you differentiate this, you get 1 over s ds. I hope you can see that. So du ds equal to 1 over x is the same as this. And when you integrate this, you get s squared over 2. Don't add class C. Very good. So you put down your formula, the integral. The I here is representing the whole of this, and that is what I made it to be I1. But here I don't want to bring that I1 again. The first one is the original integral, and that is equal to u times v minus the integral of v du. So what is u? Our u represents ln s, and what is v? Our v represents s squared over 2. I hope you can see what I'm doing. Minus the integral of v. V is s squared over 2. And du is 1 over s ds. Very good. So we are left with only these two integrals. Now you can see that what is left here, it's going to be nice for us. But let's assume that you choose your integral to be equal to s. Charlie, it won't help you. Alright. So, in fact, if what you chose won't help you, you realize it from here. So here you can see that we get half s squared ln s minus. Now, what is the constant here? Half. Bring it out. Integral of this and this, s squared over this. We get x because the half is already out. Dx. And we are going to get half s squared ln s minus half, then we integrate. Don't forget, this cancels this, so you get x, alright? So it's going to be left with x. So what's going to be integral of s? And that is s squared over 2 plus c. Therefore, our final integral function, don't forget, jot this one down, alright? I will use another, we will go by using another method to derive it, and you will see that we get the same solution to this. Very good. So now, you can see that with this, we are going to get half the integral, which is the original question, is going to be half s squared ln s minus, we get s squared over 4 plus c. So that is going to be the final answer for such question. Very good. We are still journeying through. Let's look at our fourth example. What about integral of ln s ds? Now, if you want to integrate ln s, we treat it in the same way to be a product rule, because we don't know how to integrate ln s straightforward. But we can see that if we set our u to be ln s, our v will be left with what? Who can tell me? Oh, I would like to see you. I would like to see you. What is that? Tell me over here. It will be left with 1 ds, because the coefficient here is 1. And the u here is going to give us 1 over s ds. I hope you can see that. And this one too, when you differentiate, you get x, you get x. So by substitution, integral of ln s ds is going to be u v minus integral of v du. And u is what? Ln s. V is s minus integral of v is s. Then du is what? Times 1 over s ds. Beautiful there. Now this cancel this. So ln s, so we get s ln s minus, when you integrate 1, you get s plus c. We can factor s out here, and we get ln s minus 1 plus c. Very good. So this is the integral of ln s. Don't forget that. But please, I beg you, it doesn't mean that now you know this for integral of ln s. Don't still go and challenge yourself to say that, oh, I can set my v to be integral of ln s ds because I know that of it and I can quote it. You quote, but you suffer on your way to your destination. Alright? So let's assume we don't know. Okay. Alright. Let's look at another one. What if you have, so you can also realize that anytime we know for exponential and polynomial and exponential, u is always this. Then for polynomial and natural logarithm, the u is always this. Sorry, the u will always be the leaders. Then the rest will be for that. Don't forget that. Always. video and try your hands on this. You should be able to pause the video and try your hands on it by applying this approach. Alright, so I'll come back with another method and I'll solve this question with you. But for now, because of time, let me run up with it and try it on your own. Fifth question. Let's look at integral of s sine s ds. Integral of s sine s ds. This is a polynomial of a power n to a trig function, whether sine or cos. How do we do that? In the same way, here you can let u to be equal to s, then v to be equal to the integral of sine s ds. I hope it's clear. So the u will be equal to ds, then the v will be equal to the integral of sine. You get negative cos s. So when you put down this, sine s will be equal to uv minus integral of v du. So u is s, v is negative cos s minus integral of v. V is negative cos s du. Du is equal to what? ds. Very good. So we get negative s cos s, again, for integral of cos s ds. Finally, s cos s plus. Integrate this, you get sine s plus c. So this becomes the final answer for this. So hope you can see the generalization. Anytime a polynomial meets with a trigonometric function, whether cos or sine, you can pick the u to be the what? The polynomial. Then the rest becomes that. Very good. Very good. In some books, they also choose u to be equal to the trig function. They will all work. Alright. Let's look at this. Question 6. Integral of x squared sine 2s to the power 3. So straightforward, u is equal to s squared, du is equal to 2s ds, v is equal to integral of sine 2s. Oh, let me ignore this for now, alright? Not that it can be solved, it can be solved. ds. V will be equal to. Now, when you integrate this, what do you think it will be? Don't forget something. Whenever you integrate sine ax ds, the result is going to be 1 over a. Then integrate cos, you get negative. Integrate sine, you get negative cos ax. This is how you're going to do. You get 1 over the constant here. This is a generalization I'm giving to you. It's a generalization. So here you get 1 over 2, then the next because then sine, integral of sine gives negative cos 2s. You can say the result is equal to u and do those tasks, but that's what you're going to be arriving. That's all. So then this represents the I. So this is going to be equal to uv minus integral of v du. U is what? S squared. V is negative half cos 2s minus integral of v negative half cos 2s ds. Okay, sorry. Don't forget that what will come here is the same thing that will come here. Negative half cos 2s. Then du is what? 2s ds. Therefore, we get negative s squared cos 2s all this over 2 minus negative. Don't forget that this negative is affecting the what? The whole of the inside. So negative here gives what? Positive. And the constant here, this can cancel this. So we get integral of cos 2s multiplied by s ds. Woo! I hope you are taking note of some things. The repetition of integration by parts here that we have now is something like the same as, or let me say, it's something like, let me forget about this. Look at the polynomial. After integrating by parts for the first time, the power has now reduced to 1. You see here it was power 2, now it's power 1. That means that we need to go again. And when we go again, you can see what we are going to get. Alright. So the power determines the number of times you will go. Alright. You can check from where we're having this question. That is why we had something like I3. Okay, we go by parts 3 times before arriving at it. But if here is just x, we go only 1 time. Don't forget the techniques behind these things that we are doing. So here we let, so this is just the I. So let's let I1. Now I don't want to use I1, I2 again. I'm using I here representing the main question. So I1 here representing this, what is integral of cos 2s. Oh, let me bring that here. So by parts, let's go by parts again. Okay, so I1 is going to be equal to uv minus integral of v du. So u is x. Then the v is integral of cos 2s. So du is equal to ds, v is equal to, integrate this, you get half, don't forget, the constant, 1 over, then you get sine 2x ds. In fact, we are going to see something beautiful here. Alright. By substitution, I1 is going to be equal to u, which is s, times v, which is this. Hey, where from you? Go away. Alright. get 1 over this, then integrate cos, you get sine, then you bring it inside. You can set this, you can write this somewhere and solve it. You get this. U is this, V is half sine 2s minus the integral. How we know that formula already? That is what is here. UV, okay, the integral of V du is ds. Very good. I hope you can see where we are getting to. Half s sine 2s minus, what is the constant here? 1 over 2 integral of sine 2s ds. Now that you can see that we can just integrate this. This is not by part anymore. So here is half s sine 2s minus half. When you integrate this, you are going to get negative cos 2s. Then go 2 here, all over 2 plus c. As I said, you can choose not to bring it in case you will not forget when you are coming back to write it back to this side. So here you get half s sine 2s minus. Now, again, you get cos 2s all this over 4 plus c. Finally, our answer is going to be never forgetting that the I is the integral of the original version, s squared sine 2s ds is going to be equal to, and this is the I, so let's write negative s squared cos 2s over 2 plus I1 plus I1. This is the same as this. So plus I1. And what is I1? What is I1? What is I1? Plus half of s sine 2s all this over 2 plus cos 2s all this over 4 plus c. Very good. So that is the final answer for such question. Thank you. But we are still not yet done. Let's move on to solve more questions on this part. But I hope you can appreciate something, that whenever a polynomial meets with a trigonometric function, please, it doesn't matter. This place can be cos. Alright, let's look at something now. I would like to test you on something. If I have integral s squared sine 2s squared ds, which technique is that? Integration by parts? Is it because you are in integration by parts, that is why you are saying that? Okay, what if I change this to power 3? Is this still integration by parts? Watch here. Is this still integration by parts? No! It's not integration by parts. Never! Never. Why am I saying that? If you set u to be equal to this, 2x to the power 3, differentiate this and see. Look at it. Look at it. The power here is greater than the one here. How many times? One time. That means that when you differentiate this, this will reduce to 6x squared. Hope you can see that. ds. And you can see that we can make ds the subject. This is simply use substitution. We can make ds the subject, alright? And when you make ds the subject here, you get du over 6x squared. And by substitution, don't forget that the whole of this is u. So by substitution, ds is du over 6x squared. And this cancels this. So you'll be left with 1 over 6 integral of sine u du. And you can integrate it. So this is just u substitution. Hope you can see that. So it's not, you have to test it before you go back integration by what? Part. Alright. Hope it's clear. Alright. Looking at this question, we have seen the case where a polynomial meets with an exponential function, and where a polynomial meets with a trigonometric what? Function. And we are saying that you set your u to be equal to the polynomial. But what if the exponential function meets with the trigonometric function? Don't forget that they are all transcendental functions. The limit, the exponent, the trig, whether sine, cos, whatever, they are all transcendental functions. So, how do we do that? Very good. How do we do that? Very good. So let's see. Here, let me tell you straightforward. You can set any of them to be your u, alright? You can set any of them to be your u, yes. But we would like to set, I'm coming, but as I first said, you can set any of them to be your u. But there is one which is easier than the other, alright? When you set one of it to be u, it's going to be easy. But in all, you're going to get the same thing, alright? So you don't worry. Let's choose. Let u to be equal to e raised to power s. So when you let u to be e raised to power s, then your v is going to be the integral of cos s ds. So the u will be equal to e raised to power s ds. And the v, in fact, always you set this to be equal to u. And this is going to be sine s. Why do I always want to add s? Sine s, not as plus c. So the integral function is this. Cos s ds is going to be equal to watch uv. Don't forget the formula. uv minus integral of then this v will repeat. Then you bring the u. It's not anything difficult. So I is equal to that. So u is what? E raised to power s multiplying the v, which is sine s. minus integral of v, which is sine s, and du there is what? E raised to the power s ds. Oh! Repetition again. Repetition of integration by part again. Hope you can see that. Very good. Let's continue. So here, I know the reason why I'm repeating this. Alright? Cos s ds is equal to e raised to the power s Let's I1 be equal to that part, integral of sine s e raised to the power s ds. Therefore, the whole of this, which is I, representing this, don't forget, I'm representing this by I. Is going to be e raised to the power s sine s minus I1. So I1 is going to be u v minus integral of v du. So what will be your u? So having this, in the same way, let u be the exponential function, which is e raised to the power s. So the u will be e raised to the power s ds. V will be everything left, which is sine s ds. So v is going to be negative cos s negative cos x. So by substitution, I1 is going to be uv. U is e raised to the power x. V is negative cos x minus integral of v, which is negative cos x, du, which is e raised to the power s ds. So we get here to be negative e raised to the power s cos s, and again, integral of cos s e raised to the power s ds. There is something beautiful, preciously, awesomely happening here. Now, there is a repetition of integration by parts here. I hope you can see that. Here, I want to take my time so that you can catch what I'm catching. But this is not new to us. We have seen this before from the original question. We know that the I here, which is the original question, is the same as what is repeating here. Beautiful. Fantastic. Alright. Therefore, I would like us to do something. And what is that? We don't want to go again by saying let I2 be equal to this. Because, see something. After the first by parts, initially it was cos. After the first by part, we had here to be sine. After the second by parts, we are having here to be cos. When you go for the third by part, you get here to be sine. If you go for the fourth, you get here to be cos. In fact, this e raised to power s will also be repeating because no matter how or any strategy you differentiate your u, it will still be e raised to the power s. And no matter how you integrate cos or sine, it will still be of its what? Friend. What is the friend of cos? Sine. What is the friend of sine? Cos. Beautiful. So now, let's do something. I hope you have written this side. We know that if I is equal to this, then the whole of this is I1. I'm doing modification. When you can do modification in your book, you have to write it up. Okay. So right after here, then come to this side. But we said that I is equal to this, right? And we know that the I is this, so write it down. And the I1 is what we are having here. Okay. So let's write e raised to power s, or let me bring it on top small. E raised to power s cos s ds is going to be equal to e raised to power s sine s minus I1. And the I1 is what we are having here. So e raised to power s cos s ds. E raised to power s sine s minus I1. And the I1 is this. So we get negative e raised to power s cos s plus integral of cos or e raised to power s first cos s ds. That is I1. So we get this. E raised to power s sine s, and again, or e raised to power s. Don't worry, you see what I want to derive to you. Don't worry. Cos s, and you will have it. Negative to this, negative. Integral of e raised to power s cos s ds. Woo! So what we are having here, it is same as what we are having here. Brother, don't go, or sister, if not, the ladies will say, I want to limit them, alright? Sister, brother, don't go and do by part again. If not, you will never finish. You will never finish, alright? Okay, so let's quickly end now. Send this to this side. You realize that when this comes to this side, you get 2 integral of e raised to power s cos s ds to be equal to e raised to power s sine s plus e raised to power s. Alright, so that is where we are. Now to get this is the question. So to get this, we divide both sides by 2, divide both sides by 2. So this cancels this. Then we get the integral of this to be this. But don't forget that at the end we add plus c. So that becomes our final results for such question. I hope it's an interesting question. Very good. Now let's go and look at this. maybe our last question under this part before we move to the second method in solving integration by part. So here, integral of s ln s squared dx. With this, in the same way, set u to be equal to the whole of this, which is ln s all squared. So du will now be equal to, don't forget that if we're differentiating this is general power rule. So 2 multiplying the whole of this. Subtract 1 from it, you get power 1. Then you differentiate the inside. That is why you don't need to forget your calculus 1. So when you differentiate the inside, you will get 2 ln s. Don't forget, when you differentiate this, you get 1 over s. So all this over s. So that is what we have for this part. So we get du is equal to this ds. Alright? Or let me write it, du over ds is equal to 2 ln s over x. 2 ln s over x. So that is that. Yes. Now, what will be our v? Our v will be everything left, which is s squared ds. So v will be equal to s to the power 3 over 3, no plus. Okay. So that is that. Then by substitution, the integral, the I represent this, is going to be equal to u v minus integral of v du. So u is what? U is ln s squared. The v is 1 to the power 3 over 3 minus, so u v, so minus v, which is s to the power 3 over 3 times du. And what is du? Du is everything we have here. 2 ln s over x ds. So our integral, our final result is going to be s to the power 3 ln s all squared, all this over 3 minus, don't forget that this cancels this, and the constant we have here is 2 over 3. That's the constant we have here. So to be left with s squared ln s ds. Ooh. We are still having integration by parts again. Then we need to go by parts. We need to go by parts again. Very good. So let's go again. So from what we have, I1 is equal to integral of s squared ln s ds. Okay. So our u now is ln. Our u now is just ln s. So the u is equal to 1 over s ds. And our v is integral of s squared ds. So v is s to the power 3 over 3. I hope you can see that. Alright. So here we have du, we have v, we have u. Then let's go back and do our substitution using the same formula. So we get I1 to be UV. U is ln S times V. V is S to the power 3 over 3 minus the integral of V. V is S to the power 3 over 3 times du. And du we have here is this. Very good. Now we can see what we have. So V is this. Du is 1 over S ds. So I1 is just S to the power 3 ln S, all these over 3, minus, here the constant is 1 over 3. Integral of this times 1 of this, we get what? S squared ds. So therefore, please, I hope you can see. I want to train it. First of all, set your U to be this. Differentiate this, okay? But know that it did not call you. So you go by that, and what you are going to get is this. And the rest is what? Oh, I made a mistake. The rest is our S. Oh. How we can see the mistake? It's just S, not S squared. But don't worry. If here is X, here is going to be squared over 2. Or should we maintain it? Here is going to be squared over 2. Here is going to be squared over 2. Alright. Here is going to be squared over 2. Here is going to be, okay, now let's see. So with this cancel one of this, so here is going to be just X. Then the constant here, this will cancel this. Alright, so this one will go. Very good. And then, okay, so you can see that this is integration again. Or you can see what you have in here. This is integration again. In the same way, okay, this part is right, this part is right. So this is integration again. So our U is the same as this, that is this, V is this. So when you integrate this, you get squared here and 2 here. So by substitution, we get squared here, 2 here, squared here, 2 there. Sorry for this mistake. Alright, so this is what we have. So we get this equal to ln. So we are going to get S squared ln S over 2 minus. Then here, this cancel one of this. So the constant is half. Then we get integral of what? S ds. You can even maintain it to be the power 2 and solve it. Alright, it will change anything. You get the concept that you need. You get the concept. So I1 is equal to S squared ln S over 2. I changed it that I don't want to contradict from the question. Minus half And when you integrate that, you get S squared. Alright, so that is I1. So by substitution to this, where is I? I is equal to this. Is that also? That is this. That is it. So I is this. This one will go. So we know that this is I. And we set this part. Let me reduce the I. The I will just be S squared ln S over 2 all over 2 minus integral of S ln S ds. So this is what we set it to be equal to I1. This is what we set it to be equal to what? I1. Alright? So now, the whole of this is what? I1. And you know I1 is equal to what? What we have here. So, therefore, if this is I1, then S squared ln S power 2 over 2 minus the whole of this is I1. Alright, so now go and write this. S squared ln S over 2 minus half S squared. Very good. So you can see that, you can now see that with this is not the same as this. So don't say this is cancel this. Here we have the square of this, we don't have the square of this. Alright, so here we can rewrite this as, since it's having the same denominator, we can rewrite this as S squared ln S squared minus S squared ln S minus S squared. All this is over 2. All this is over 2. And we can get this to be, here we can factorize S squared out. And when you factor S squared out, you now get ln S squared minus ln S minus 1. All these over 2 plus C. So that is going to be the final answer for such question. Very good. Alright. So let us now move on to the second part, then we close for this session. Integral of theta sec squared theta d theta. Here u is this because that is like the integral function being in terms of what? S. And we are integrating as respect to S. This is theta, so that is theta. Du is equal to the theta. And the rest will be integral of what? Sec squared theta d theta. So when you integrate this, you know that when you differentiate tan, you get sec squared. That means that when you integrate sec squared, you get tan. So this is tan theta. Alright, therefore, the result is going to be uv theta tan theta minus the integral of v, which is what? Tan theta d theta. Alright. So therefore, our final answer is going to be theta tan theta minus, when you integrate tan, what will you get? Hope you remember that you get ln sec theta plus tan theta plus c. And that becomes our final result for that. Thank you. See you in another video where we are going to look at table of integration is another technique that we use to solve integration by parts.